Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about some basic concept of pericyclic reactions. I hope this video will be fruitful for you. If you like this video, then subscribe my channel. So friends, let us start our topic today in this video. Basic of pericyclic reactions. So I will start from the note. So when we move in molecular orbital, the sign of orbital change above the plane or consider all orbital below the plane is called anode. For a linear conjugated system, pi system, the wave function psi n will possess n-1 node. If n1 minus 1 is 0 or even integer, psi n will be said to be symmetric with respect to m and antisymmetric with respect to C2. If n-1 is an odd integer, psi n will possess the C2 symmetry, axis of symmetry, and antisymmetric with respect to m. So psi 1 node 0, psi 2 node 1, psi 3 node 2, and psi 4 node 3. Now electrocyclic reaction process in which two pi bonds convert into one pi and one sigma bond and vice versa. Ring opening and ring closing. If the substitutions are present on the rotating carbons, also rotate in the same direction. Two atomic orbital forming a sigma bond may be rotating in opposite directions, one in clockwise and other in anti-clockwise manner. This is called disrotatory process. Two atomic orbital forming a sigma bond may be rotating in same directions either in clockwise or anti-clockwise manner is called conrotatory process. Now frontier molecular orbital methods. Molecular orbital model for analyzing pericyclic reaction has been proposed by Kenichi Fukui of Japan. The correlation diagram is useful for the details analysis of an electrocyclic reactions. Let's take one example, 1,3-butadiene converted to cyclobutene. You can see here bonding molecular orbital symmetric A, B, C, D and forming the bonds. So here what is the correlations? A antisymmetric with X, B symmetric, C2 axis of symmetry and mirror plane of symmetry. So antisymmetric, antisymmetric, symmetric, symmetric, antisymmetric, antisymmetric and symmetric symmetric. But C2 axis of symmetry is just crossover. So look at here, bonding molecular orbital and anti-bonding molecular orbital, 1,3-cyclohexadiene and 1,3,5-hexatriene. So symmetric, antisymmetric, symmetric, antisymmetric, symmetric, antisymmetric in case of C2 and opposite in case of plane. In the same here, in plane, antisymmetric, symmetric, antisymmetric, symmetric, antisymmetric, symmetric. In case of C2 is opposite. So frontier molecular orbital method. The correlation diagram is useful for the detailed analysis of electrocyclic reactions. A similar conclusion is obtained by considering the symmetry of highest occupied molecular orbital of open chain partner in electrocyclic reaction. If the HOMO having C2 axis of symmetry node is odd, then reaction will follow conrotative path. If HOMO possesses a mirror plane symmetry node is 0 or even number, a reaction will follow disrotative path. So thermal reactions, transition state and configuration preference. 4n plus 2 aromatic and 4n anti-aromatic. 4n plus 2 aromatic follow disrotatory in case of thermal and 4n conrotatory in case of thermal. It is different and opposite in case of photochemical reactions. So a similar conclusion is obtained by considering the symmetry of highest occupied molecular orbital of open chain partner in electrocyclic reactions. So you can see here B is symmetric with C2. So conrotations thermal. Here in photochemical C is symmetric to M, so disrotatory. Now you can see here how disrotatory in case of light and photochemically disrotatory and thermal conrotatory. So these are examples. So triene skeleton of cyclooctatetraene undergo electrocyclic reaction closure reactions. The total number of electrons take part in the reactions are 6. Therefore, HOMO of the reaction is psi 3. The node of the reaction is 2. Therefore, M plane of symmetry is maintained. The M plane of symmetry has maintained by this root. The process total electron 6, HOMO psi 3, node 2, symmetry M. Process allowed disrotatory. Process thermal total electron 4, HOMO psi 2, node 1, symmetry C2, process allowed conrotatory. So you can see here conrotatory and disrotatory, it gives two products. Now major product formed by the photochemical reactions you can check. Now cycloaddition reaction. It is a class of pericyclic reaction in which the system having m pi electrons is added to the system having n pi electrons, forming cyclic products. It is versatile, good for the synthesis of cyclic compound having high degree of stereoselectivity under thermal and photochemical reactions condition. Depending on the number of pi electrons taking part in the reaction is called as M plus N and M plus N cycloaddition reactions. A concerted combination of two pi electron system to form a ring of atoms having two new sigma bonds and two fewer pi bonds is called cycloaddition reactions. You see 2 plus 2 cycloadditions, 4 plus 2 cycloadditions, 4 plus 2 cycloadditions, here 2 plus 2 plus 2 cycloaddition reaction. Now in cycloaddition reactions, addition of two systems having double bond take place either in same or opposite side of the system. Such mode of addition is very important to decide the stereochemistry of product, and these different number of modes are named as suprafacial or same side and intrafacial on the opposite side. This specification is usually carried out by keeping a suitable subscript S or A after the number of referring to the pi components. The Diels-Elder reaction is also called as 4s plus 2s cycloaddition. Suprafacial, heat, intrafacial. So a cycloaddition reaction is allowed or not, which can be found to depends on the symmetry properties of the highest occupied molecular orbital of one reactant and the lowest unoccupied molecular orbital of other molecule. The favorable interactions can be predicted from the sign of homoelement. During cycloaddition of ethylene to cyclobutane, 2s plus 2s addition is thermally forbidden because lobes of HOMO of one ethylene molecules and that of other LUMO of another ethylene molecules are not having corresponding similar sign. 8. 2Na plus 2s thermally allowed, but when one ethylene molecule is irradiated on electron get excited to excited state, antibonding molecular orbital, which is now become HOMO, which is then correlated to the LUMO of other unexcited ethylene molecules. Therefore, it is photochemically allowed. So, ground state forbidden, excited state light allowed. So, 2 plus 2 cycloadditions is allowed through the light. In Diel-cell radiation, the sign of 1,4 lobes of butadiene HOMO have been found to be matching those in the LUMO of ethylene. So 4s plus 2s addition is thermally allowed and photochemically forbidden, where 4a 2s plus 4s plus 2a is photochemically allowed and thermally forbidden. The Diel-cell radiations of cyclopentadiene forming cyclopentadiene, invariably the endodimer is formed rather than exodimer because of favorable secondary force due to interaction of frontier orbital of diene and dienophile compounds, which lead to the lower energy of the transitions. Now, the most common cycloaddition reaction is the 4pi plus 2pi cycloid known as Diel-cell reaction, in which cyclic product is formed from alkene and di. The stereochemistry of the substituents attached to the double bonds carbon atom is maintained. The diene contains electron donating groups, while dienophile contains electron withdrawing groups, are easily undergo 4 plus 2 cycloaddition reaction. These are examples. Here 2 plus 2 plus 2 cycloaddition reactions also. This is also another example, stereochemistry. These are many examples. You see the pseudo-ortho and pseudo-para. These are many examples of Diel-cell radiations. You can see here, if SA2 is present, the reactions contains 8 electrons, therefore occurs with con-rotatory motion into trying terminal. If the electrophile chelotropic reaction is linear, if the HOMO of SO2 reacts superficially as it does in the case of diene, and triene must react intrafacial, which is consistent with the observed con-rotate. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.